All right, now we have another combustion reaction. Instead of ethylene, we now have ethane. C2H6 has 2 carbons and 6 hydrogen atoms in each molecule of ethane. And it is reacting. It's ethane gas. It's reacting with molecular oxygen in gaseous form. And they combust to form carbon dioxide gas and liquid water. And like we've seen in previous examples, this chemical equation is not balanced. How can we tell? Well, here on the left-hand side, we have 2 carbons. Here on the right-hand side, we have 1 carbon. Here on the left-hand side, we have 6 hydrogens. Here on the right-hand side, we only have 2 hydrogens. Here on the left-hand side, we have 2 oxygens. On the right-hand side, we have 2 plus 3 oxygens. So none of the elements here are balanced. But like we did in the example with ethylene, whenever you see this where you have several somewhat complex molecules involved, it's good to save the element that is in a molecule by itself for last, because you can just tweak this to change the number of oxygens without having any other side effects on the number of carbons or hydrogens. So what I'm going to do is I'm going to first balance, like we've done before, the carbons and the hydrogens, which are going to have implications on the oxygens, because if I change the number here, it's going to change the number of oxygens. If I change the number here, it's going to change the number of oxygens. But lucky for me, I have this dioxygen molecule on the left-hand side that I can just tweak at the end to balance the entire chemical equation. So let's start with, last time we started with carbon, let's start with hydrogen this time, just for kicks. So over here, I have 6 hydrogens on the left-hand side. On the entire left-hand side, I only have 6 hydrogen atoms. On the right-hand side, I only have 2 right now. So if I want to have 6, I would multiply these 2 by 3. So now I have 3 water molecules. Each of them have 2 hydrogen atoms. So I'm going to have 6 hydrogen atoms on the right-hand side. Fair enough. Now let's go to the carbon. Remember, I'm saving oxygen for last. Carbon on the left-hand side, I have 2 carbons. How many carbons do I have on the right-hand side? Well, right now I only have 1, but I can change that very easily. Instead of having 1 molecule of carbon dioxide, I can have 2 molecules of carbon dioxide. And so now my carbons are balanced. 2 carbons, 2 carbons. And now let's go to the oxygens. So right now I'll do this in a mauve color. Right now on the left-hand side, I have 2 oxygens. But on the right-hand side, what do I have? Let's see, I have 2 times 2. So this right over here is 4 oxygens. And then I have 3 water molecules. Each of them have 1 oxygen atom. So 3 times 1, so this is going to be 3 right over here. So on the entire right-hand side, I have 7 oxygen atoms. And on the left-hand side, I only have 2. So what can I do here? What can I multiply by 2 to get to 7? 2 times what is equal to 7? Well, 2 times 3.5 is equal to 7. So 2 times 3.5 is equal to 7. Remember, I have 2 here. I'm saying 2 times something is equal to 7. I want to get to the 4 plus the 3. Well, I multiplied it by 3.5. And now I have 7 oxygen atoms on both sides of my chemical equation. But like we've seen in previous videos, it is not standard to just leave a 3.5 here. It's kind of this weird notion of 3.5 molecules. We like to have whole numbers here. So how do we make sure we have all whole number coefficients in front of our molecules? Well, we could just multiply everything by 2. Then this thing is going to become a 7, this thing is going to become a 2, this is going to become a 4, this is going to become a 6. So let's just do that. I'll write the whole reaction over again. So I have my ethane, and I won't write actually what state it's in, just to save some time, plus some molecular oxygen. They combust, they yield. So these are the reactants. The products are carbon dioxide gas and liquid water. So let's see, you multiply, if you say that there was a 1 out here before, we're going to multiply that by 2 to get 2. We had a 3.5 here, multiply that by 2, you get a 7 here. We had a 2 right over here, multiply that by 2, you get a 4. Once again, I'm just multiplying all the coefficients by 2, just like you did in an algebraic equation in your algebra classes. And then finally, 3 times 2 is 6. And we're all balanced. We were balanced here, but we didn't have whole number coefficients. Multiplying everything by 2 gave us the whole number coefficients, and we are much happier.